Good day. My name is Dr. Ewumbua Ajayi-Banji from the Agricultural and Biosystems Engineering Department at North Dakota State University. And today I'm going to be taking you on a presentation on evaluating the allowable storage time of two mature soybean varieties at 4 moisture levels and typical storage temperatures. We will all agree that the soybean supply chain is complex, from agricultural production to storage, processing, transportation, manufacturing, retail, and consumption. During soybean breeding, new varieties are developed that actually alter the genetics. For example, North Dakota produces shorter season varieties because we have a short season of planting. The end use of soybeans also causes alteration in the genetics in the case whereby the soybean is breeded for high or low protein or for high or low oleic or linoleic oil, which is for healthy oil. Because of these reasons, it's important for us to look and see what happens during storage, if there are any differences between the different variety types of soybean. But most importantly, this research aims to focus on updating updating information on soybean allowable storage time, because in 2019, for instance, due to the US-China trade war, we saw an increase in on-farm storage for farmers here in the Midwest area. And that meant that farmers had to keep their beans longer than they usually would. And there was a need to have information about what moisture content at what storage temperatures they needed to store their soybeans to be able to keep it and preserve it and maximize their returns. Secondly, crushing plants are springing up here in North Dakota and surrounding states, and there's a need for us to have seeds stored all year round. And because of that, we need that information to be able to determine how long we can actually keep our soybeans to maintain quality. The current soybean storage recommendations that are available now are based off of corn allowable storage time data. And there's a need for us to do research that actually deals with the soybean seeds itself. Moreover, the corn tables from which the soybean storage tables were developed dates back to decades ago. Those data were only available decades ago. So to be able to evaluate the allowable storage time, what we did was to obtain soybeans at two different suppliers. We have ND1709 GT and EL8023. They were obtained at their harvest moisture of about 9%, and then we conditioned them in this green mixer to form moisture content of 11, 13, 15, and 17%, which is typical of the moisture content at which farmers will store their soybeans. We put them in these plastic bags to retain the moisture, and we put them in this large black tot at 3 different storage environments at 5 °F to represent what happens in the storage in the winter month, at 40 °F what we see during the fall and the spring month, and then at 72 °F for summer months. So these beans were put inside the storage containers at this environment for a period of 12 months. The moisture content was monitored every month to ensure that the target moisture was maintained, and we had hobo data loggers used to inside the stot to monitor the storage temperature. Additionally, we had a sample of 13% moisture content soybeans that was actually rotated within the tree storage environment at a sequence of temperature of 40 °F to represent fall and spring, to 5 °F to represent winter, back to spring at 40 °F, and to 72 °F to see what happens during the winter month. So quickly to our results and discussion, what did we find out? First of all, these are the allowable storage time quality parameters that we analyzed. We analyzed for germination, the total fungal count, we took into account that's the mold and the yeast count, the free fatty acids of the oil, the peroxide value, and of course the moisture content and temperature was actually monitored. So what did we find out? For the seed germination, we found out that moisture content, variety, moisture content, temperature, and storage time had a significant effect on the seed germination with these p-values that are less than 0.05. And that was the same thing we also found out, the effect of all the storage factors on the total fungal count. We also saw that all the storage factors were actually significant at p-values less than 0.05, showing their influence on the seed germination and the fungal count. Now, effect of storage conditions on seed germination. What we observed was that for the two varieties at 11% moisture content, we observed that over the period of storage, the 12 months of storage, what we observed was that we had germination percentage that was almost 100%. But when we look at the 13% moisture content seeds for the two varieties, what we could see was that while the germination was maintained for the cold room and the freezer, for room temperature samples, we saw that right after week 28, we had a drop in germination below 80%. And for the second variety, EL8023, right after the 16th week of storage, we had a drop in germination to about 50%. Now, the minimum germination for certified soybeans by the Association of Seed Certified Agencies certify soybeans for minimum germination at 80%. So that actually served like as a baseline for us to determine the percentage at which point, right, that we could actually store the seed longer based on germination. Now, quickly, let's take a look at 15%. For the 15% soybeans, we saw that right after the 16th week of storage, we had a drop below 80%. The same thing after 12 weeks of storage for this particular variety, EL8023, we had a drop in the germination. But one interesting thing that we observed here is that the ND7009 GT actually maintained germination percentage above 80% up until week 16, while it was lesser here because we saw the drop by week 12. And for the 17% seeds for both varieties, we saw that for room temperature here, right after the 4th week for both varieties, we had a drop below 80%, while the cold room and the freezer samples were actually maintained at about 100%. But one other interesting thing that we found out was that despite the fact that we had greater than 80% germination at week 4 for both varieties at this moisture content of 17%, we observed that by week 2, we began to see secondary infection, as we can see in this picture on the germinated seedlings. Now, we went further to look at the effect of storage conditions on the seed fungal count, taking into account both the mold and the yeast count. For 11% moisture content for both varieties and at the tree storage environment, we observed that the seed fungal count was relatively stable. However, when it came to the 13% seeds, we saw that by week 24, for ND7009 GT, we began to see an increase for room temperature samples. And the same thing is actually observed here. Earlier, for EL8023 by week 16, we saw an increase from the initial 2.30 CFU per gram of mold. We saw it going to about 4.0. And now for the 15%, as early on as week 8, we saw that the initial log counts for both varieties had doubled, above 4.0. And for the 17% for both varieties, we saw that as early on as week 4, supporting the data that we had for germination, we could see that it had more than doubled the initial value of the log count, more like close to 200% increase in the fungal value. So we had a fungal set limit for ND7009 GT for 4.0 CFU per gram, and for EL8023, 4.74 CFU per gram, which was based on the data that we had for germination. So what we did was we did not put the fungal count set limit at a time when we could see this increase in the mold, but at the point whereby we had the initial log count doubling, at that point, when we were counting the plate, what we observed was that even though we're not seeing mold on the seeds, technically because we're having the high presence of mold in our plate count, we set that as the fungal set limit for our allowable storage time. That's based on the fungal count. Now, for effect of storage conditions on free fatty acid content and peroxide value, the free fatty acid content was relatively stable for samples stored in cold room and freezer. However, for samples stored at room temperature, we observed that for 17% samples for both varieties, right after the 4th month, which is the 16th week, we had values exceeding 0.75%, which is the recommended limit. However, for peroxide value, we saw values were very low, less than 5.0, which is the maximum limit for low oxidation. Now, based on this, we developed an estimated allowable storage timetable based on the data we had from germination, the fungal count, and the oil quality, which is the free fatty acid and the peroxide value content. And this is what we came up with. We came up for the two varieties at the tree storage temperatures, and we have the storage time here in days. So if you look at this particular chart, you will see this red marker showing that the two varieties showed different allowable storage time in days at this moisture content and at this temperature. And the same thing we're seeing here. And of course, this is for the additional experiments that we had for 13%. And what we saw interestingly was that the allowable storage time was 360 days. We're able to maintain the quality of the beans as we move this across the sequence of temperatures in storage. Now, allowable storage time chart that was developed decades ago, allowable storage time ESC table developed decades ago is shown here. So this first one, the source is Kenneth Hellevang, and this was updated as at 2018. And what we can see here is the moisture content, and we can see the green temperature, and we can see the AST time, allowable storage time in days. So a comparison was made on this from this chart based on the estimates that we had from our study. One thing I would like to quickly highlight is that the data that we can see here was extrapolated from the one for corn. So where you see 11% moisture content for soybeans here, what that meant is that that was 13% moisture content for corn from corn tables, right? So a quick comparison between this table and our table showed us that at 11% moisture content, for grain that was stored at 70F, the AST time days here is 200 days. However, for our study, what we recorded was 360 days, showing us longer time for the beans to keep in storage. Also, for the 13% moisture content soybeans, we have 70 days for storage at 70 degree F. However, what we have recorded here is longer time in storage for the varieties we worked with. Here we're having 210 for variety A, ND1709 GT, and 150 days for EL8023. A quick look at the 15% moisture content as well at 40F. Here we have 200 days for the AST. Here we have a longer time in storage, 360 days. And for the 70 and for the 70F at 15%, here we have 40 days, here we have 30 days. However, when we look at the 17%, we can see that they have 90 days from this table, and what we are seeing here is longer days, 120 and 270 for both varieties. But the 17% at 70 degree F is actually the same. So what we're seeing here is that from the study that we had, we are seeing that we are able to keep our beans longer compared to what we have in this chart. Could it be because of the the alteration in genetics and the newer varieties that are being produced for different end use? We'll find out as we proceed. Secondly, this is also one of the old tables that we have, a allowable storage timetable that dates back to decades ago. But this particular table was calculated on the basis of 0.5% maximum dry matter loss. This was based on an Iowa State University research. And what we also observed here is that for 40 degree, quickly, so the moisture content highlighted, bolding in red in this rectangle here, is showing the soybeans moisture content. And what we have here is for corn moisture content. So it was estimated for soybeans less 2 points for moisture content of corn. So quickly, at 40 degrees F, 11%, they are saying 150 months because this table is in months. And what we have here for 40 degree F, at 11, we have 360 days. So we are saying that they can store longer based on this chart. Okay, let's look at what happens at 15% at 40 degree F. So 15%, 40 degree F, we are saying 360 days, which is about 12 months, but here they are saying 29 months. So what we actually saw from their table is that they are based on the 0.5% maximum dry matter loss that they used to actually develop their table. We're saying that they can actually store soybeans longer. Now, based on this estimate, what does this inform? What does this tell us? This tells us that there are differences in the old EST tables, the data for the old soybean EST tables, and the recent estimates that we are actually having from our study. Also, one other interesting thing that we found out from our study is that soybean variety ND1709 GT showed better storage potential than EL8023 based on the germinability and the fungal development. We also observed that at low temperatures of 5 degree F and 40 degree F, fungal count and germinability was relatively preserved for longer storage period than what we had at 72 degree F, which represents room temperature. Definitely, germination percentage was influenced by an increase in the moisture content, the storage temperature, and the time. So going forward, what we have to do is we have an ongoing allowable storage time research, but this time we're looking not just at 2 varieties, we're looking at 3 different varieties, and we're now bringing into account their relative maturity groups. And those maturity groups are from within the Midwest here, North Dakota, Minnesota, and South Dakota. They're about to be specific. So based on the data that we draw from this research, it will help us to validate the findings from the previous research year, which is going to help us to be able to come up with a new table that will be helpful to both farmers, processors, and industry generally as regards the allowable time of mature soybeans, as the end goal is for them to be able to maximize profit as farmers. I would like to acknowledge the North Dakota Soybean Council for funding this research. I would also like to acknowledge the input of the American Association of University Women for their support when this research study was being carried out. Thank you to NDSU for the facilities that we used to do this program, and for ASAB as well for the platform to be able to present the findings of our research. Thank you so much for listening, and I can be reached on these details if you have any questions. Thank you.